Good morning, student. At the outset, I must congratulate Pandit Ravi Shankar Shukla University, particularly School of Studies in Mathematics, for providing a very ultra-modern facility for lecture capturing. I have no words to express my deep sense of gratitude to Professor Balwant Singh Thakur, Head of the Department, Dr. Jipti, as well as Mr. Indra Kumar and Abhishek Katendra for giving me this opportunity to discuss one of the very important lecture for integrated B.Sc. B.Ed student. Dear student, as you know that Pandit Ravi Shankar Shukla University has already started that 4-year B.Sc. B.Ed course, and it is called an integrated teacher education program. And we are regularly teaching them. Now this topic is based on the third semester student B.Sc. B.Ed, and the title of that course is Inorganic and Physical Chemistry, and there are 5 units. What I have decided that I will discuss the unit number 4, and that is related to the electrolyte conductance. It is a very important course. So let me start this course. As you know, whenever we start any course, the student must know the actual course content, and that is the course is CBSC 0CT. So the main topic is the electrochemistry, and I think I need at least 6 lectures to cover whole electrochemistry course of 3rd semester. Now first, I have broadly categorized into 4 main aspects. Number 1, electrolyte conductance, the first part. Second part, we will discuss the theory of strong electrolytes, Debye-Huckel theory, Debye-Huckel-Onsager theory, and like that. Then, of course, you know that the migration of ion is very important. That is called the transport number. I will discuss all these things. And lastly, we will discuss the electrochemical cell. So that means there are 4 major aspects. But today, I will concentrate only on the electrolyte conductance. And particularly in electrolyte conductance, I will take 2 lectures. In first lecture, I will discuss the fundamental concepts of electrolyte conductance. What is electrolyte? What is conductance, like that? And in second part, I will discuss the specific conductance, equivalent conductance, molar conductance, and then of course I will also discuss 2 important laws. One is called, you all know about this thing, the Ghosh dilution law, as well as the Kallol law, and then of course conductometric titration and other things. And then in theory of strong electrolytes, we will also discuss the limitation of the Ghosh dilution law, Debye-Huckel-Onsager law, and ultimately, finally, I will discuss the electrochemical cells, particularly electrode potential, Nernst equation, polarization over potential, and hydrogen voltage. I think now you have got a clear-cut idea about your course content. Now let me proceed again for the, as you know that because you are in the university teaching department, is one of the prestigious, oldest university of our country, and recently this university been awarded A+ grade by the NAC. So we always recommend you to study some of the standard textbooks. You can also refer any undergraduate book, like there are many books available in our library, like Physical Chemistry Puri Sharma Pathania, Physical Chemistry by Behal and Puli, Physical Chemistry by Negi and Anand. But here I will particularly have referred one of the very old book, but best book, that is an Introduction to Electrochemistry by Samuel Blaston. Many copies are available in the library. You can refer. Second book, for some derivation purpose and definition, the units, I have referred this book, Physical Chemistry by Ira and Levine. And in addition to that, you can refer Physical Chemistry by Atkins. You can refer the Physical Chemistry by Albert and Daniels, and you have to concentrate only that electrochemistry chapter. Okay. Now let me start the subject. Now whenever we start the topic, my topic is electrolyte conductance. So if I ask you, do you know what is electrolyte? Number one. How do you define the conductance? And most importantly, why do we study this whole electrochemistry or the conductance? Now, first point is that you know that there is a national education policy system. The student must know the program outcomes. Student must know the course outcome. Like program, why this conductivity study is important? Because you know, when we take any acid, base or any salt, dissolve in water, so it produces the ions. So that is called the electrolytes. And then of course, all the electrolytes have some capacity to conduct the electricity. And it is a very, very important topic, because if you purchase a water purification unit in your house, sometimes you measure the total dissolved solid like that. So therefore, this is very important subject for the purification of the water, then the application of the water, how do you know the dissolved salts in the water. So that is some theoretical part. In biological system is also, this plays a very, very important role. You all know regarding the electrolyte imbalance, sodium, potassium balance, calcium ions and other things. So it is directly related to the health problems like that. So first is the academic field or some industrial water, drinking water, purification of the water. Second is the biological, I have already discussed. And if you want to learn about the industrial field, if you see the industrial field, if you want to prepare some battery, electroplatings and other things, so it is also very important. So that means in overall, what I can say, क्यों हम लोग electrolyte conductance को पढ़ते हैं? Because it has got tremendous applications in all sphere of life, particularly in biology, जैसा हमारा nerve conduction, muscle contraction, also based on this the migration of the ion. This is a transport phenomenon. Then the industrial. So therefore, this knowledge is critical in various fields like chemistry, biology, environmental science, industry and pharmacy and the medicine, formulation of the drugs and other things. So I think the students, you can now understand that what is the importance of that electrolyte conductance. Therefore, we are studying that particular chapter. That is the, so after learning the course, you are able to learn or discuss the importance of this electrolyte conductance. Now I am coming to actual things. As I told you that the definition of that conductivity is the ability of a material, any material, like I am not talking about the strong electrolyte or weak electrolyte. It may be acetic acid, it may be potassium chloride, to conduct the electricity. It is a good conductor of the electricity. Similarly, when we dissolve that material or electrolyte in a solution, particularly in water, it dissociates the ion. So that is also important. And then this current carried by that ions. So in electrical conductivity, flows of electric current through that electrolyte. That is the definition of the conductance, and therefore it is a ट्रांसपोर्ट फिनोमेना, क्योंकि बिकॉज इसमें माइग्रेशन ऑफ द आयंस होते हैं. मैं अभी आपको सेल से दिखाऊंगा. एंड इट कैन बी कैरिड बाय दैट ट्रांसपोर्ट फिनोमेना, इलेक्ट्रिकल चार्ज कैरिड बाय द electrons or ions moves through the system, and it depends upon the, I am not talking about today the mobility of the ions. It depends on various factors. Temperature may be one of the factors, solvent is one of the factors. So that is the definition of electrolyte conductance, or what is actually conductivity, conduction of. It is a transport phenomena, and basically there are two types of electrolyte. One name itself is the definition. One is the strong electrolytes. Like if I take the hydrochloric acid, it immediately dissociates hydrogen and chloride. And if I take acetic acid, it also dissociates acetate ion and hydrogen. But the extent of the dissociation is less. So in next lecture I will discuss about the degree of dissociation. Okay, so I think conductance is now clear. Now I am taking one example, that if I take a if I take if I take a pot and I think color maybe dark blue, this color is this, and I am taking one electrolyte, maybe potassium chloride, and taking two electrodes. I am talking about the electrolyte cell. Don't confuse with the galvanic cell. One is, of course, you know that cathode, another is the anode, and some external applied field is immersed there. So if I apply some potential difference, one is anode, another is the cathode. So the migration of the ions, that is cations to cathode. Suppose sodium ion like that will come there. Chloride ion. So that is the migration of the ions. But how do I measure this migration of the ions like that? So the key properties is the resistance. So resistance, because next part is the definition of the observed conductance, definition of the specific conductance, definition of the equivalent conductance. But उसको जानने से पहले हमको resistance को जानना पड़ेगा. Resistance is an extensive property. आप इसको दूसरे ढंग से भी कैलकुलेट कर सकते हैं. We have to, of course, take the help of the great Ohm's law. You all know this, the Ohm's law. What is Ohm's law? So resistance is an extensive property of the system, since it depends on the size and shape of the current carrying device. Because if suppose there is two electrodes and the distance between these two electrodes is 1 centimeter or 1 meter, and cross sectional area is 1 square centimeter square like that. So it depends upon this thing, the resistance. And 1 by resistance is the conductance. I'm just coming to that point. So I'm taking this information from these are fundamental points. A student must know this point that suppose there is the electric current is I, okay, and the rate of flow of charge through that electrolyte, you can write like that, you see, dq capital Q divided by dt. What is that Q? So dq is the change. Change is the charge that passes through that cross section of the conductor in the particular time. So electric current per unit cross section area. So that is the J, electric current. So that is equal to I divided by A. I is the current, A is the cross sectional area. So how do you define the conductivity? It is nothing but the electric current density with respect to electric field. Now, how can I explain these things? Now, this is the most important thing. Just please see it very carefully. That if I take resistance of a system, it is directly proportional to the length of that electrode and inversely proportional to the area of cross section. You can change this notation. There is no problem. Or I can write like that: R is equal to some L divided. R is resistance and rho is the resistivity. And if the value of L divided by A is equal to 1 unit, so that resistance is exactly equal to that resistivity. Similarly, if I write 1 by R is the conductance and 1 by rho is the specific conductance. So if the distance between two electrodes is 1 centimeter and area of cross section is 1 square centimeter. So the observed conductance is exactly equal to the specific conductance. And so electrical conductivity, there is a kappa, the symbol, don't worry for that, you can write like that. Electrical conductivity or specific conductivity is also kappa dash. So now, because if you see some old books, the unit may be written as the mho, because the unit of resistance is the ohm. And you all know that this ohm means it is coming from the great scientist Ohm's law. I will of course explain the Ohm's law just a minute. So electrical conductivity, now the symbol is kappa and the unit is the Siemens per meter or per centimeter. It depends upon the distance. So it measures how easily the electrons move through the material. The ability of the material to conduct the electricity, ability of that material, and the inverse of the resistance. If the resistance is R, 1 by R, and the unit of R is ohm, so it is ohm inverse 1, just like that. And that is sometimes it is called the mho. Or you can call it the volts per ampere like that. So it is a mho. But now, and as you know that higher the conductivity, the better the material conducts the electricity. It is very quite simple. But bear in mind, because you are in the B.Sc undergraduate classes, B.Sc B.Ed student, maybe not aware of this new unit, but now actually the unit of conductance is not mho, exactly, but it is Siemens, capital S like that. एंड यू मस्ट नो व्हाई इट इज सीमेंस, क्यों इसको सीमेंस लिखा जाता है, बिकॉज इसको एक जर्मन इलेक्ट्रिकल इंजीनियर, उनका नाम है हांस वेर्नर वन सीमेंस। तो आपको कोई कंफ्यूजन नहीं होना चाहिए। ओम्स का जो नाम आया था वो ओम्स जॉर्ज ओम के साइंटिस्ट के नाम से है, और ये जो सीमेंस जिसको हम लोग एस से लिखते हैं, माइक्रो सीमेंस, मिली सीमेंस, जब आप एक्सपेरिमेंट करेंगे तो आपको समझ में आ जाएगा। और ये उनका फोटोग्राफ्स है, एंड आई एम टेकिंग दिस फोटोग्राफ्स फ्रॉम द इंटरनेट, एंड आई एम ऑल्सो गिविंग द सोर्स ऑफ दैट जहां से हमने लिया। अब हम बहुत संक्षेप में आपको बताते हैं कि द कंडक्टेंस ऑफ द इलेक्ट्रोलाइट सोल्यूशन, it depends upon the types and concentration of the ion. So that means, of course, if you measure the conductance of the acetic acid, उसका वैल्यू दूसरा आएगा। इफ यू मेजर द कंडक्टेंस ऑफ पोटासियम क्लोराइड, उसकी ऑब्जर्व कंडक्टेंस अलग होगा, क्योंकि उसकी इफ यू मेजर द कंडक्टेंस ऑफ 1 मोलर एसिटिक एसिड, उसकी ऑब्जर्व कंडक्टेंस की वैल्यू अलग आएगा, अभी मैं बताऊंगा आपको। इफ यू टेक 0.001 m, उसकी कंडक्टेंस की वैल्यू अलग आएगा। So that is the types of the concentration and the ion. Similarly, of course, temperature effect is not very significant, but जैसे अगर आप टेम्परेचर को चेंज करेंगे तो आपकी कंडक्टेंस की वैल्यू चेंज हो जाएगा। उसी तरह से जब हम सॉल्वेंट चेंज करेंगे, बेसिकली मोस्ट ऑफ द केसेस वी आर टेकिंग दी water. I am not talking about the electrical conductivity. I am not talking about the thermal conductivity. So viscosity of the solvent. नेक्स्ट लेक्चर में मैं समझाऊंगा कि ऑब्जर्व कंडक्टेंस क्या है। अब आ जाते हैं हम लोग, हाउ डू वी मेजर दी, नाउ आई थिंक यू अंडरस्टैंड दैट व्हाट इज कंडक्टेंस, व्हाट इज इलेक्ट्रोलाइट्स, व्हाट इज स्ट्रॉन्ग इलेक्ट्रोलाइट, व्हाट इज वीक इलेक्ट्रोलाइट्स। अब हम आते हैं कि कंडक्टेंस को हम कैसे मेजर करेंगे। नाउ फॉर दैट वी नीड ए इंस्ट्रूमेंट, और उस इंस्ट्रूमेंट का नाम है कंडक्टिमीटर। इन सम बुक्स इट इज रिटन लाइक कंडक्टिविटी बी। मेनी गुड कंपनीज मैन्युफैक्चर दैट कंडक्टिविटी। उसमें एक इलेक्ट्रोड होता है, मैं अभी आपको बताऊंगा। And generally we follow the Ohm's law, and this is the photographs of this great scientist George Ohm। और ये मैंने फोटोग्राफ्स इंटरनेट के ब्रिटानिया, ये उसका सोर्स है। तो जैसा भी मैंने आपको बताया कि कंडक्टिविटी में एक सेल होगा जिसको हम लोग कंडक्टिविटी सेल बोलेंगे। एंड इफ यू आस्क मी सर व्हाट इज, Ohm's law is very simple, that voltage, if I applied some voltage potential difference, it must be equal, it is directly proportional to the I, current, intensity of current, and the resistance, or I is equal to V by R. You can write very simple thing. Similarly, that resistance, if I take, अभी मैं फोटोग्राफ दिखाऊंगा कि मैं एक सेल कैसे बनाऊंगा, 2 इलेक्ट्रोड आपने लिया, so that R is डायरेक्टली, अभी थोड़ी देर पहले मैंने आपको बताया, डायरेक्टली प्रोपोर्शनल टू दी एल एंड इनवर्सली प्रोपोर्शनल टू द एरिया ऑफ क्रॉस सेक्शन। So and that is called the resistivity. So resistivity that can be, मैं वहां पे रो लिखा था, तो इसको भी हम रो कर सकते हैं, हम रो लिख देते हैं। अलग अलग बुक्स में आपकी रो कर देता हूं, तो मैं ताकि यूनिफॉर्मिटी रहे। आप कुछ भी लिख सकते हो, ऐसा कोई प्रॉब्लम नहीं है, ये भी आप लिख सकते हो। सो दैट रेजिस्टिविटी इज इक्वल टू आर ए डिवाइडेड बाई ए, एंड 1 बाई आर, ये भी मैंने अभी आपको बता चुका हूं, 1 बाई आर इज द कंडक्टेंस, एंड एज बिकॉज इसको हम लोग स्पेसिफिक 1 बाई रो इज द रेजिस्टिविटी, और it is called the specific conductance. And so how do I define the unit? So ये हुआ मोल, और ये क्योंकि L है सेंटीमीटर मान लीजिए, और इसका एरिया ऑफ क्रॉस सेक्शन सेंटीमीटर स्क्वायर। तो ये आपका हो गया सेंटीमीटर, ओल्ड यूनिट। और अभी हम लिखेंगे तो ये सीमेंस, एस सेंटीमीटर में, और अगर हम मीटर में लिखेंगे तो एस मीटर इन। So now you can understand the length of the conductor, length between the electrodes. अब इलेक्ट्रोड कैसा दिखता है? Now I can show you that electrode. So now you can understand that I have to determine the conductance of any electrolyte. So first we need a conductivity bridge. Then of course we follow the Ohm's law, we apply the Wheaton bridge, you all know. And now we need a cell. So I am giving here, there is a cell. देखिए आपको दिख रहा होगा, ये पॉलीमर से ढका हुआ रहता है। आपको अगर बहुत ध्यान से देखेंगे उसमें 2 इलेक्ट्रोड है। बेसिकली वो प्लेटिनम का इलेक्ट्रोड रहता है, और उसमें पोलराइजेशन ना हो तो उसको हम लोग ब्लैक कोटिंग किया जाता है। मे बी अदर मेटेरियल, बट मोस्ट ऑफ द इंस्ट्रूमेंट वी आर हैविंग दैट पर्टिकुलर प्लेटिनम इलेक्ट्रोड। और दोनों के बीच पे डिस्टेंस जो रहता है तो स्लैब दिखेगा, आप देखेंगे जब आप प्रैक्टिकल करने आएंगे। तो पोलराइजेशन टिपिकली प्लेटिनम का होता है, जैसा भी हमने। इन एडिशन टू दैट देयर मे बी सम अदर टाइप्स ऑफ मटेरियल, स्टेनलेस स्टील और अदर मटेरियल कैन आल्सो बी यूज्ड, एंड ऑलवेज देयर मस्ट बी रेंज। दैट मींस इफ यू आर India make instrument, so you can measure from 0.01 microsiemens per centimeter to 1000 millisiemens, and of course temperature range maybe some minus to plus 100 you can measure. For that of course we need that a thermostat. So the first part is that before performing the experiment you have to measure the cell constant. तो आप पूछेंगे सर व्हाट इज सेल कांस्टेंट? बिकॉज कभी कभी क्या होता है कि जो दोनों इलेक्ट्रोड के बीच का डिस्टेंस जो है वो 1 सेंटीमीटर नहीं होता है, और एरिया ऑफ क्रॉस सेक्शन भी 1 सेंटीमीटर स्क्वायर नहीं होता है। So sometimes it is called the calibration of that equipment. That is, you have to monitor that cell constant. और इसको आप बोल सकते हैं cell constant is nothing but the L divided by A. And most of the instrument, they are using the electrode or conductivity cell. The cell constant is approximately 1 centimeter या 1 meter, ये रहता है. But in some cases maybe more than 1 or less than 1. But we have to determine this thing. अब प्रश्न आता है कि हम सेल कांस्टेंट को कैसे निकालेंगे. फॉर दैट you have to prepare 2 or 3 solutions of a strong electrolyte which is called the potassium chloride. आपके मन में प्रश्न आना चाहिए, सर why we should take the potassium chloride? Generally, I am not saying in our laboratory or in your laboratory you will use the potassium chloride. टीचर आपको बताएगा कि prepare 2 or 3 solutions of potassium chloride. बेसिकली हम लोग लेते हैं 0.01 मोलर या 0.02 मोलर or even sometimes 0.1 molar. Why? Because it is the aqueous KCl solutions have very stable. Once you prepare this KCl solution, you can use for 7 days or 10 days like that. If your water is pure, then it is reproducible and well known conductivities at different concentrations and the temperature. And the strong electrolytes, so it completely dissociates potassium ion and the chloride ion. और सबसे important बात है कि for the calculation of cell constant you need the accurate values of specific conductance of KCl in different concentrations. So you will get all these values from the literature. That means the values are available in the literature. Second, that KCl is chemically inert. So it will not react with the electrodes or any other solvents, basically water. So आपको समझ में आ गया होगा कि अब हमको कंडक्टिविटी मेजर करना है। कंडक्टिविटी मेजर करने का पहला भाग ये है कि हमको सेल कांस्टेंट निकालना है। सेल कांस्टेंट निकालने के लिए हमको KCl का 2 सॉल्यूशन बनाना है। अब कैसे इसकी फॉर्मूला करेंगे, देखिए बहुत इजी है। R अभी मैंने किया L/A, agreed? So this, I think color, maybe should I do the red? And this L/A ठीक कर देते हैं। ठीक होता है क्या? ठीक, ठीक है, थोड़ा मोटा कर दीजिए। यस, ओके ओके ओके। सो अगेन आई एम जस्ट टाइपिंग R L, yes, now you see it. So this L/A, suppose this is X, this is X. X means X is the cell constant. Or if I, that means R to rho, like that. So X. So 1 by R, you know, 1 by 1 by X. So 1 by R, what is the color? Color. Yes. Now 1 by R is the observed conductance. You can write kappa. And 1 by rho is the specific conductance. Specific conductance. Kappa dash. So I can write like that. Observed conductance into X into specific conductance. So X is equal to specific conductance. Last time just give me 5 minutes divided by the observed conductance. कभी कभी ऑब्जेक्टिव टाइप प्रश्न पूछा जाता है। जनरली if the cell constant is 1, so the value of observed conductance is exactly equal to the specific conductance. तो अब कैसे आप निकालेंगे सेल कांस्टेंट? स्पेसिफिक कंडक्टेंस ऑफ these solution can be taken from the book or literature. ऑब्जर्व कंडक्टेंस आपने जो अलग अलग सोल्यूशन बनाए हैं उस सोल्यूशन का कंडक्टिविटी निकालेंगे, उसको वैल्यू करेंगे, जो वैल्यू आएंगे वो होगा सेल कांस्टेंट। अब मैं एक एग्जांपल आपको देना चाहूंगा, लास्ट हो गया इसके बाद। यस, नाउ आई एम शोइंग दिस वैल्यू, दिस एक्सपेरिमेंट were performed by the M.Sc chemistry student of School of Studies in Chemistry, Pandit Ravi Shankar Shukla University. And that determination of cell constant, verification of Ostwald dilution law is already given in the YouTube lecture as well as our university के जो वीडियो लेक्चर में उसको है। तो जो स्टूडेंट्स को देखना चाहे उसको देख सकते हैं। तो मैं ये जो वैल्यू यूज कर रहा हूँ मैं उस वैल्यूज को यूज कर रहा हूँ जो हमारे स्टूडेंट ने एक्सपेरिमेंट कर चुके हैं. So for example, I am taking 3 solutions. First is 0.02 molar potassium chloride, 0.0 m potassium chloride, and the specific conductance values I have taken from the books. I am not mentioning the book, like 0.002768 Siemens per meter. दूसरा सोल्यूशन हमने फिर बनाया उसका डाइल्यूशन से 0.01 m, उसकी वैल्यूज हैं स्पेसिफिक कंडक्टेंस 0.0014, एंड आई एम टेकिंग दिस वैल्यू फ्रॉम लिटरेचर. आपके कोर्स में ये भी है, वो मैं नेक्स्ट लेक्चर में बताऊंगा, द इफेक्ट ऑफ डाइल्यूशन, बिकॉज हियर most concentrated solution is 0.1 m, then 0.02, then 0.01. And if you see the values of the specific conductance, it is decreasing. तो अभी तो मैं आपको डेफिनेशन नहीं दिया हूं कि स्पेसिफिक कंडक्टेंस कैसे हम निकालेंगे, बिकॉज टुडेज लेक्चर इज द फंडामेंटल इंट्रोडक्शन, व्हाट इज इलेक्ट्रोलाइट कंडक्टेंस, व्हाट इज इलेक्ट्रोलाइट्स, how do we calculate the cell constant and how measure the conductance. I will not discuss the what is specific conductance, what is molar conductance, equivalent, ये नेक्स्ट लेक्चर में होगा, जस्ट हमको समझाने के लिए. नाउ ये ऑब्जर्व कंडक्टेंस हमारे स्टूडेंट ने इंस्ट्रूमेंट के द्वारा निकाला. अभी थोड़ी देर पहले मैंने आपको बताया कि दी फॉर्मूला इज वेरी सिंपल, दैट सेल कांस्टेंट x इज इक्वल टू whatever the value of specific conductance divided by the observed conductance. So I'm getting, they get 0.892, 1.029, and the average value 0.96, which is approximately 1. So I'll summarize the thing, and I have taken this because it is already available in the YouTube and our university website, so therefore I am just giving the references of that. That means of course ये जब हम आपको एक्सपेरिमेंट कराएंगे, ये हमारे MSc के स्टूडेंट्स हैं, ये YouTube में ये ऑलरेडी है, एक्सपेरिमेंटल सेक्शन ऑफ पोस्ट वाल डाइल्यूशन लॉ, डिसोसिएशन कांस्टेंट ऑफ द एसिटिक एसिड, ये बहुत पुरानी, तो मैं इसको जस्ट आपको रेफरेंस के लिए दिखाना चाह रहा हूँ कि मैं जो वैल्यूज हैं वो मैं आपके यहाँ से लिया हूँ. तो लेट मी समराइज. टुडे आई हैव डिस्कस्ड द very fundamental aspects of electrolyte conductance. बहुत ही संक्षेप में मैंने आपको समझाया कि व्हाट इज इलेक्ट्रोलाइट, स्ट्रॉन्ग इलेक्ट्रोलाइट क्या होता है, वीक इलेक्ट्रोलाइट क्या होता है, the ability of the electrolyte to conduct the electricity, and I also discussed the units of resistance, unit of conductance. मैंने आपको बहुत ब्रीफली समझाया कि how do I measure the conductance, how do we measure the cell constant, and ultimately I have given some values of observed conductance and specific conductance. Now one last point is that whenever we measure the observed conductance of any electrolyte, your solvent, that means the water, must be very pure, otherwise you will get some conductivity value of that water. So it must be less than 1 microsiemens, 1 into 10 to the power minus 6 Siemens, like that. It must be very new. In my second lecture, part 2, because this is the fundamental, but second lecture I will explain the actual meaning of how do you explain the specific conductance, molar conductance, equivalent conductance, and what is the effect of the dilution. And then of course in third lecture I will discuss the Oswald dilution law, and then gradually we will discuss the Onsager equations and Debye theory and other things. So thank you very much. Thank you very much.